Okay, it's recording. Okay, sorry about that. So let's start off with the land acknowledgement. We acknowledge we are hosting the lands of Mississauga of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognizing the enduring presence of all First Nations, Métis, and Inuit people. Okay. Today is Wednesday, July 17th, day 12. So you guys would, as like I said yesterday, you guys are doing the unit test today. Unit 4 test, okay? That's 3 parts: application, thinking, communication. Okay, it was available from 12 a.m. today, like from last night. Okay, and it's due today at 11:59 p.m. Okay, I just want to make sure you guys can access this. I'm going to come in as a student, so I want to see what you guys can see. Okay, so the link should all work. That takes you to the application. Yep, application question. Okay, go back. That should take you to the thinking questions. Yes, it does. Let's go to the next one. And this should take you to the communication question. And it does. Okay. So we got all questions there. But we are starting Unit 5 in this lesson today. We're going to go through Unit 5, discrete functions. There are worksheets associated to this lesson. And then there's a quiz. This quiz is actually going to be available tomorrow. Okay, so if I click on this link, it shouldn't be available. It says here it's available tomorrow. Okay, or midnight tonight. Okay, so and basically you get 2 attempts, and it's 60 minutes, and there's 8 questions. Okay, so you don't need to worry about this quiz because, well, you should worry about a quiz, but a quiz is only going to be available tomorrow. That means today you're going to focus on, doing this test, which is due today, and then you can go through the worksheets. Okay, so please remember, like I said before, do not miss unit tests. It's going to impact your mark. If your mark's not so good, that means from now on you have to submit everything. Okay, in order to pass the course or do well in the course. Okay, so please focus on getting everything in by the due time and date. Okay, so let's go into content, and we're going to start Unit 5. So Unit 5 is the last unit we're going to work on. Okay, our first lesson is going to be arithmetic and geometric sequence. Okay, so there's no video here, so we're just going to go through the lesson. You can see this is what the general formula looks like for a geometric sequence. Okay, this is sort of a general formula used to come up with what is this sequence of numbers. So let's get into it. Okay, so here you go, right? So when you look at these numbers here, right? 1, 1, 2, 3, 5, 8. Okay, can you guys figure out what the pattern is? Anyone? If you look at it, what will be the next number? What will be the number after this number? After 233. If you look at the pattern, you can see a pattern. Anybody? Use your calculator. Nobody? Okay, well, let's see here. How did you get that? What did you do? You can type in the chat. What did you do? it looks like what you did to get that number was you added the previous two numbers. Yes, okay. So in order for me to get 1 from my next number, I had to do 1 plus the previous number, which is 0. To get 2, I had to add the 2 previous number. To get 3, I had to add a 2 previous number. To get 5, I had to add a 2 previous number. To get 8, so to get 233, I had the 2 previous numbers. So there you go. So that's the pattern you see there. Okay, for the general formula, formula that represents any term in a sequence relative to the term of the number. Okay, so a formula that represents any term in a sequence relative to the term number. Okay, let's look at that again. Now, what is sequence? Okay, an ordered list of numbers identified by a pattern or rule that may stop at some point at some number of continual indefinitely. Okay, so let's look at that again. Zoom in here. Here's an example. Okay, an ordered list of numbers identified by a pattern or rule that may stop at some number of I should say, or continue indefinitely. So here is a set of numbers. It stops here. Here's a set of numbers that actually goes on dot dot means it continues forever. Okay, so dot 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 means it's going to continue forever with that same pattern. Okay, so note the terms of the sequence represent the range y values of a function. The terms of the sequence represents the y represent the range, which is the y values of the function. Well, range does deal with y values. Remember that from our regular functions, right? And domain deals with x values. Okay, so let's look at this first example here. And with this first example here, we're given a formula, right? And then it says here, write the first 3 terms of each sequence given the explicit formula for the nth term of the sequence. Okay, so you were given so looking at the first 3 terms, so that means we're going to say term 1, which is T1, T2, and T3. Well, if I'm talking about T1, right, I'm going to put in my first term, right? The nth term is the first term. So we're going to put in 1. The T is the actual value. N is the number, like within that sequence. Like if I look at over here, let me just make sure you guys understand what we're talking about. This is the actual value, but this is the first term. If you look at my mouse, right? This is the first term, second term, third term, fourth term, okay? Well, the value of the first term is 3. The value of the fourth term is 15. So the value of the fourth term is 15, okay? And that is the fourth term. So over here, this is the first term. The value of it is 2. And if we go on well, let's look at the fourth term here. The fourth term here. So this would be considered N4. This would be considered N1. Now, the 15 would be considered the term value at the fourth term. Okay, the term value. This one here, number 3, will be considered T1, which is the value at the first term. Okay, so that's what we're trying to figure out here. We know the term, it's the fourth term, but we don't know the value, and that's what we're trying to calculate here. Okay, we know the first term, which is N1, but what is the value? And that's what we're trying to calculate, okay? So let's look at this example here. My first term which is n1. So my first term, the value of my first term, when you do the calculation, put 1 there, it equals to 2, okay? Because 1 to the power of 2 is 1, okay? And then 3 times 1 minus 1 gives you 2. So that's the value of the first term. Now the second term, n now is equal to 2. The value of the second term is 11. And then the value of the third term is 26. So my first three terms, term 1, term 2, term 3, are 2, 11, 26. Okay? That's from this formula. Okay? Now we're given this formula and same sort of thing. We got to calculate what is the term values at the first three terms. So my n and the first term is going to be 1. My n in the second term is going to be 2. My n in the third term is going to be 3. Okay? So now my value of the first term is 0. My value of the second term is 1/2. My value of the third term is 2/3. Okay, so the first three terms are 0, 1/2, and 2/3. Okay, so that's just the basics. So now we're going to get into arithmetic sequence. Okay, so here we looked at arithmetic sequence. It's when you look at this sequence of numbers, the first term to the second term to the third term to the fourth term, dot, 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 means it's going on forever. The pattern looks like you're going from one term to the next, you add 4. Okay, one term to the next, you add 4. Okay, so we can do that forever. This one here, this sequence, the value from term to term looks like minus 4. Okay, and so on. So when you're dealing with arithmetic sequence, what is constant between the sequence of the numbers is the value that it goes up and down. Okay, so there's a constant increase or a constant decrease. Okay, so that's what makes this arithmetic sequence. It's a constant increase, okay, between each term. Okay, so if you look at, this is the general formula, okay, for your arithmetic sequence. I start off with the first term, okay, n is your term. A is your initial value. So what is my initial value? Okay. And now I'm dealing with the first term minus 1 times the common difference added to the first term. That will be your general formula. Okay. So let's apply it to here. Okay. So now determine a formula for the general term for the following arithmetic sequence. Okay. So when we say what is the general formula, here's the general formula. But we need to figure out what are these values. N, we already know what n is, right? We know what n is. N is just the term number. So that stays there. What's the variable is the A and the D. Okay? So when you look at this set of sequence, you're looking to figure out what's your A and what's your D. A is the first term, so that's easy. But what's your D? The D is the difference between each term. So when I write down this general formula, Tn's equal to A plus brackets N minus 1D, I need to find out what's my A and what's my D. So now here is now my answer. Okay. So now once I have this, I can use this formula to figure out what would be, for example, the 30th term, right? Because remember, this goes on dot, 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 dot forever, right? So I can figure out, what is the value of my 100th term? Okay, here's the question here. What's the value of my 30th term? Okay, n is 30. So the value of my 30th term, you use this formula that you created. You plug in 30, you plug in all the variables you know. The value of my 30th term is going to be 130. Okay? So when you have the sequence, you can figure out what is your general formula because you know what your A is, which is the initial value. You know what your D is, the difference between each term, right? In this case, it's +4, okay? And then you come up with that. And then the question could be, what's the value of the 30th term or 100th term or the 20th term? Here's another question. Determine the general formula, the general term, determine the formula for the general term for the following arithmetic sequence, okay? So you're trying to find the general term from the general formula. Okay, here's my sequence. 7, 3, -1, -5. Okay, well, that's the sequence. What's the difference between each term? -4. Okay, what's my initial value? 7. So I plug it into the general formula to get the general term. Here's my general term. Now, my general term value, I want to know what's the term value at my 41th term. Plug it in, I get -53, right? Which makes sense because I'm going down by -4. That means they're all now into the minus. So if I go all the way down to term 41, it definitely should be a minus. If I have a positive number, then I know I made a mistake. Okay. So we talked, okay, this is coming in late. We talked about arithmetic sequence. Now we're going to talk about geometric sequence. The difference between geometric sequence and the arithmetic sequence is that between each term, you are looking at a difference or adding or subtracting, basically a difference between each term, which stays the same. In geometric sequence, what you're looking at is a multiple between each term, okay? So when I go from 2, 6, 18, 54, there's a multiple there. There's not a difference that's the same. It's the multiple that's the same. So I go from 2 to 6 and multiply by 3, 6 to 8 multiply by 3, 18 to 54 and multiply by 3. So the multiple is the same, it's constant. And if you look at this example, 80, 40, 20, 10, the multiple between each one is a half. Okay, we're not going to use the word division. We're going to use multiple. So if I'm shrinking, that means I'm shrinking by a fraction. In this case, the fraction is a half. So I multiply each term by a half, and each term is getting smaller by a half. Okay. So in other words, the geometric sequence is ratio of the consecutive term is the constant. So basically what I'm saying is from each term, I'm increasing or decreasing by constant multiple. In this case, it's a half. In this case, it's a 3. Okay. So the formula for the general term of a geometric sequence is, this is what you see here. Okay. So n, you know, is the term number. A, you know from before, is your first term. The thing that's new here is R. R is your multiple, constant multiple, okay? So it's telling you here, no, you're not going to be dividing by 2, you're going to be multiplying by a half. So my multiple here would be R is equal to a half, okay? Let's look at the examples here. Example 4. Determine a formula for the general term of the following geometric sequence. So we want to find out the formula for the general term. Okay, so here's your sequence: 2, 6, 18, 54, 162. Our R, right, is 3 because it's multiplying by 3 each time. And our initial value is 2, so A is 2. So that becomes your formula, the general term formula. Now the question is, what is the value of the 9th term? So just going to plug in 9 where n is, and then you figure out what that 9th term, which makes sense, it's such a big number, right? So if I'm multiplying each term by the time I get to the 9th term, I'm going to get a big number, right? So that makes sense, that answer there. Let's look at another example. Looking at this example here, determine a formula for the general term for the following sequence. So what's the formula for this sequence? Well, I'm going from 270, 90, 30, 10. I mean, this could be trial and error to try to figure this out, but maybe if I look at 30 to 10, maybe it's easier to see. I'm going down by a third, right? 90 to 30, I'm going down by a third. So my first term is A. My multiple is 1/3. I plug it into the formula, and this is my general term formula. Now, same question, what's the 9th term? 10 over 243. I'd keep it as a fraction. I wouldn't divide it out. Okay. Okay, so we are done with the sequence. Now we're going to go into series. Okay, let's get into series. Here is a worksheet related to that. Arithmetic and geometric series. Let's look at that. Again, you're going to be using formulas. You need to calculate what is your general term formula based on the formula that we give you. So let's look at this lesson over here. Okay, so now we're looking at series before we're looking at sequences. Okay. Let's look at these definitions again. Sequence. Sequence is an ordered list of numbers identified by a pattern or a rule that may stop at some point. Okay. So that's the definition for a sequence. You had arithmetic sequence, where the difference between the consecutive numbers was constant. But if I went from the first term to the second term to the third term to the fourth term, the difference between each term was the same. Now we're looking at the geometric sequence, where from the first term to the second term to the third term, the multiple between each terms was the same. Okay. So now, what is series? Okay. Series is basically the sum of the terms of the sequence. Okay, so series is the sum of the terms of the series. Sorry, the sum of the terms of the sequence. So let's look at this. Let's look at this example here. Okay. I want to find S4. What does that mean? I want to find the sum of 4 terms of this sequence. That's what that means. Okay. So S4 means I want to find the sum of the first 4 terms. Here's my formula. Right, here's my general term formula. Now I would have to come up with the term values. So if I plug in the first term, second term, third term, and 1 and 2 and 3 and 4, I'll come up with my 4 terms. And then my sum of the 4 terms, just adding up all the values of each term. Okay, that would be your S4. That's one example. So now here is basically the general form for arithmetic series. Okay, so arithmetic series means you're dealing with a sequence that the difference is, as it increases, it's a constant difference. Okay, so if you look at this one here, this is a arithmetic series because I go up by 3, right? Between these two, 1 and 4, 7 and 10, 4 and 7, my increase was 3. So this arithmetic series deals with sequences that are in arithmetic sequences. Okay, so So you can write it like this, or you can write it like that. Okay, so here is another example. Okay, so this is arithmetic sequence, right? You can see my difference is each term is 2. I'm going to use this general formula to come up with the general term formula for the general, um, general term formula. Okay, so um, I need to find the sum of, this is saying here, the sum of 23 terms. Okay, the sum of 23 terms. Okay, my first term is 1, my difference is 2. I need to find the sum of those 23 terms. This is the formula. Okay, let's look at the next example. Example 3. I need to find the this kind of arithmetic series with 52 terms. Okay, it starts at -7 and it ends at 102. Okay, you see how it's not giving you the values in between because you don't need it, right? I need my initial. You need the initial value. It tells you it's 52 terms, and it tells you the value at term 52 is 102. So now I'm going to use this formula, and my n is going to be 52. Okay, my my value at the 52 term is 102. So now the sum of all 52 terms is, there you go. Okay, so now geometric series, that means you're dealing with ordered list that is the difference, well, not the difference, from term to term, it increases or decreases by a multiple. Okay, so that's what you're dealing with. That's what you're looking at here. And the sum of all the terms in a geometric series or sequence gives you a geometric series. So here is your formula for the geometric series. So now here's an example right here. Geometric sequence going from -1 to -16. Each term has a multiple, you can see that, of -2. Okay, so my R, which is the multiple, is -2. My initial value here is -1. So now the question says, I want to find the sum of 5 terms. That's what S5 means, the sum of 5 terms in this geometric sequence. Well, I can I can just use this formula. Well, actually, no, in this case, they don't give you the formula. They actually just give you the terms. You just add up all the terms and that's your value. But for this question here, they don't give you the terms. They just say S13. That means the sum of 13 terms. So you're going to use this formula, which is up here, and figure out the sum of 13 terms. So if I use this formula here, right, we know what the R is. The R is the multiple. We know from that question it's -2. Our N, right, from that question, we want to know 13 terms. So N is 13. That's it. Use that formula and you calculate what is the sum of 13 terms. Okay, so let us look at something that looks more real. Look at this example here. Okay, this is more real. So we're just talking sequences. Let's look at actual problem. A student is offered a job with a math teacher that will last 20 hours. Okay, student is offered a job with a math teacher that will last 20 hours. It pays, I know that's really low, I get it. $4.75 for the first hour, then $5 the second hour, $5.25 next hour, and so on. Okay, how much will the student earn in total? Okay, so when you look at this question here, you see it's increasing from hour to hour. So let me ask this question, so you guys are paying attention. Is this geometric sequence, or is this arithmetic sequence? Let's see if you guys pay attention to the difference. What kind of sequence is this? Is it geometric or is this arithmetic? Any takers? Yeah, arithmetic, yes. Why? Why do you say that? Yes, that's right. It's increasing by the same amount. It's increasing by 25 cents. Okay? From 1 hour to the next, it's increasing by $25 or 25 cents. Okay? First hour, the person was getting $4.75. The second hour, the person's getting $5. The third hour, the person's getting $5.25, and so on, right? So if you look at the, so we're looking at this using this formula, right? Well, either one, you have to figure out which one you're going to use. You're not using this formula because this is for geometric. So you're using this formula, right? Because this is for arithmetic, right? So if you're using that formula, when I go back to this example, there you go. That's the formula I'm using. And well, my A is my initial value, which is at the first hour. D is my difference between each term. And I guess each term would be, each hour is a term. Okay, so I have 20 terms because I'm talking about 20 hours. So every hour is a term. So in this case here, I plug it in. So this is what the person will get after 20 hours. Okay. Okay, so that is your series. Let's come out of here and look at the next one. Recursive functions. Let's look at that. Okay, so let's get into it. Okay, recursive functions. What is that? Okay, so earlier on we talked about the geometric series, the arithmetic series. We talked about the arithmetic sequence, the geometric sequence. So now we're going to look at recursive functions. Okay, recursive functions. Functions that get new terms in the sequence by using earlier terms. Okay, so it's a little bit different from the arithmetic sequence. Okay, so let's look at what the difference is. Let's look at this example. Okay, so write the first 4 terms of the sequence. So this is my formula, okay? And where my first term is 7, I want to write the first 4 terms. So my first term is 7, I plug in 7, I'm going to get 5. If I plug in for my second term, I'm going to plug in 5 now, I want to get 3. For my next term, I'm going to plug in 3, I'm going to get 1. okay? So the first four terms of the sequence are 7, 5, 3, and 1, okay? But you can see how each term was dependent on the previous term, okay? But I mean, you can also look at it and say, well, 7, 5, 3, what's the difference? 2? So this would be a arithmetic sequence, wouldn't it be? If you look at it that way, this would be a arithmetic sequence because I'm decreasing by a constant amount, which is -2. Here's another one, another example. I'll give you the formula, right? And we want to find the value of the first four terms. Our first term is 5. So we plug in there 5. We get our second term is 14. Then our third term is 32, and then 68. Is there an obvious pattern between these two terms, between each of the terms? This does not look like it's a arithmetic sequence, right? And it also doesn't look like a geometric sequence, right? So it's not an arithmetic sequence. It's not a geometric sequence, but it is a sequence because we have this formula to get that. So this is what you look at where you call this a recursive function, a recursive sequence, because I need the values of the previous term in order to get the next term. Okay, so let's look at it. Another example here. Okay, find the first four terms. Where the first term is 2. Okay, so that's what we see, and we see how we're writing it as a. You see how we're writing it? We're writing it as a function, right? We're writing it as a function notation. You can see that, right? So it's a function of the term. Okay, so my n is the term, but my value, okay, is a function of the term number I'm looking at. So if I'm looking at term 1 here, my function, my value is actually 2, my first term. And if I'm looking at my second term, the value of my second term is -3. Third term is -13. Fourth term is -33. Okay, so I'm looking at the function of is based on the term number. The value of the term is based on the term number. That's the best way I can explain that. Okay, so now let's look at this example here. Okay, this example here, find the first 7 terms of the sequence. Okay, well, here's my formula. And my first term is 1. Oh, it's telling my first term is 1 and my second term is 1. Okay. So you can see this formula here is based on the previous 2 terms. Okay. I don't know if you remember from the very beginning of these lessons we looked at where the following number was based on the addition of the previous 2 numbers. That's what this is here. So my term is is composed of the addition of the previous 2 terms. So if I want to get term 3, I'm going to add term 1 and 2. If I want to get term 4, I'm going to add term 2 and 3. To get term 5, I have to add term 3 and 4. Okay, so that's my sequence. You guys might have remembered this from when we did this when I showed it at the very beginning. Okay, so let's look at this one here. -3, 6, -12, 24. This is a little bit jumpy the way this is. Okay. I'm multiplying by -2 from each term. That's what it looks like. So -3 times -2 gives you +6. And then from the next term, multiplied by -2 gives you -12. So there you go. So this is a geometric sequence, not a arithmetic sequence, because from each term, I'm increasing by a multiple. You can see that this is a geometric sequence. So here's the formula. And if you were to graph it, okay, I'm going to graph that. Let's see here. Yeah, okay, so this one here, this is another question here. So 2, 6, 10, 14. The multiple is 4. So if you were to graph that, you can see it's a linear, right? So it's going straight up by each term is being multiplied by 4. Oh, this one's different. This one here is +2, +3, +4. Okay, so this is not even a geometric sequence. It's not an arithmetic sequence. Well, it's a recursive sequence. Okay, and this is the formula for that. Okay, so when I go back, I believe that is the last lesson for these sequences. Okay, there's worksheets there for each of the sequence and series questions. Okay, I think that is it for today. The quiz for this, right? There's no quiz today because I want you guys to focus on the test. So I go back to the home page. The test is what you're focusing on. But if you're done the test, the quiz is available at midnight. Okay. So you can click on that. It will show available at midnight. Right now it's not available, but it's available at midnight and it's due tomorrow at midnight. So Thursday. Okay. Today's Wednesday. So focus on the test. Get that in. We want you to get everything in. So please focus on getting that test in. Okay. And I think that is it for me to mention. Okay, so let me stop sharing my screen. And I believe we are done for today. Okay, so I'm gonna let you guys go a little bit early and we'll see you tomorrow.